All right, for part A, we are going to define h as g of f of x, and we want to know what is h of 4. And so I want to show all of my work here. I know h of x is equal to this composite function, and now I'm going to replace the input value with 4. So let's come up above. This is the graph of f of x. I'm going to find when the input value is 4, we can see the output value is 2. Okay, now we're going to use a calculator because this is a calculator-related problem. And I'm going to, there's a couple different ways I can do this, but I'm going to go ahead and just substitute in for the x a value of 2. Let's ensure that I did plug it in correctly. It looks good. Now we have h of 4 as negative 9.3. Remember, do not circle your final answer. Find all values for x for part 2, for which f of x is equal to 3. So we want to know, 1 is the y value equal to 3. So I'm going to draw a line going straight across, and then let's put this into words. So f of x equals 3 when x is equal to 5 and x is equal to 7. All right, let's look right now at part B. And so I'm going to go ahead, I'm going to plug in, make sure I've cleared my calculator. I'm going to go to y equals, and let's plug in the function g. 1.2 x to the third power, subtract 4.9 x squared plus 0.7. All right, so we want to find all of the zeros, or the x-intercepts of this function. So let's graph it. We may need to adjust the graph. That's okay. Okay, so I can see that we have a possibility of 3 real roots, and those 3 real roots are shown right here. Okay, let's go ahead. Second, trace 0. So I'm going to go left, press enter, right, and back to that point. If it's a decimal, I'm going to round to the nearest thousands, 3 places past. So negative 0.362, approximately negative 0.362. Let's do the next one. Second trace, find 0, and down and back up. Okay, we have 0.39. Okay, we got around 398. So approximately 0.398. And my last one, second trace, 0. Now we can also go in intervals in between. So I could say between like 2 and 8. And that could also be a way to achieve the answer. So this is going to be x is approximately 4.048. Part B says to determine the end behavior as x decreases without bound. So we do need to write this in limit notation, and we also need to include that we're talking about g of x. So the limit as x goes to negative infinity, because it decreases without bound, of the function g of x. Okay, and we can see as we move to the left without bound that it is going down. We can see this function is going down. So it is decreasing. All right, let's look at part C. Determining if the inverse of the function of f can be constructed for all values. So we are looking right now, we have a domain from 0 to 9, and we're going to use the horizontal line test. So the horizontal line test says when you make a horizontal line, if it crosses a function, give me one second. Let me go back here. Sorry, students were just walking in. So we can determine if a function f has an inverse, and we can use the horizontal line test with this graph. So a horizontal line can be drawn, and if it crosses the function more than once, then a function has no inverse. So it only crosses once, only crosses once. Oh, we got a problem here. It crosses here, and it crosses here. Notice it crosses here, and it crosses here. So determine if an inverse of a function can be constructed for all values. It cannot. So part A, is an inverse of f cannot be constructed on the interval, or maybe you wanted to say on the domain from 0 to 9. Now give the reason, and that's because using the horizontal line test, we're able to cross the function in more than one place. So if we went ahead and we actually set values here, so if I went ahead and I set values here, we want this function to be 1 to 1. What that means is that every x attaches or corresponds to one unique y, and every y corresponds to one unique x. And here's an example. Here's a great example right here. When I go across at 2, we can see 1 attaches to 2, and we can see 4 also attaches to 2. So this makes this function not 1 to 1. So using the horizontal line test, I can see this function on the interval from 0 to 9 is not, does not have an inverse because it is not 1 to 1. This means every x does not correspond to a unique y value, and every y value does not correspond to a unique, oh, I'm getting sloppy, a unique x value. An example, 1 corresponds to 2 and 4 corresponds to 2. Or maybe you want to write 1, 2 and 4, 2.